Hi, I'm James Taberner, and this is my video presentation for the bridge optimization assignment 1. This is, as you can see in the background, this is the bridge that we were given to do a optimization of, which is located in Whitehorse, Victoria, which you can see the coordinates were given there, where the pin located is where the bridge is. So this is how the site survey was done. We did a Google Map search and then did a street view for a screenshot. The measurements were then taken by a reference, and then the design domain was taken from that. So with the optimization design process, I first did a site visit of the bridge, made my optimization statements, solved the optimization statements using manual iterations and MATLAB, and then smoothed out those models using Abacus and verified and validated the optimal solution. And if they were validated and verified, they were then 3D rendered the optimal topology and placed over the bridge on site. So this is the design domain on the right and my right FEM on the left, which is confusing. So it's just a markup on AutoCAD given the dimensions that were measured, and then the right FEM is a markup from Abacus, screenshot from Abacus, sorry, showing the mesh and the load, X symmetry, and the fixed ends. So manual iterations were done on the left using Abacus, and that was the third iteration, removing volume after increasing the stress levels, and then on the right was using MATLAB code, giving the input parameters, which can be seen in the report. So using these, the verification and validation then occurred. This was done by looking at the maximum magnitude, as you can see in the top corner there, and then the maximum tensile and compressive strength on the bottom right. This was then done using an MCC with the max displacement to verify, which can be seen as expected. The 20 gigapascal max displacement was double that of the 40 gigapascal with the number of nodes along the x-axis there. Then seen in the table below, we can see that the strain energy for the optimal design was the lowest compared to the other iterations, which is expected, showing that it is optimized. And then using this optimized structure, we did a 3D render on Abacus and then superimposed it over the existing site, which can be seen there. Feelings on the first project, I found it incredibly difficult to start with. It was like learning a new language using Abacus and MATLAB, but I wasted a lot of time with certain iterations, but once I got on top of it, I found it was pretty good. On the upcoming assignment, I think I'll be a bit more prepared and I find it a bit more enjoyable. So thank you very much. Thanks for listening to my presentation.